morning children. In today's class we are going to continue problems on limits using L'Hopital's rule. What is the difference between the earlier class and problems of today? We will be having x in the power, x power x, sin x power x, x power sin x. Problems of this model. How are we going to do? Whenever x is in the power, differentiation or applying limit, so we may get 0 power 0, 1 power infinity, such ideas which are indeterminate. So how should we do it? Whatever is the problem given, treat it as some a or y, some new name we shall give. Take log on both the sides. If I take logarithm, power will become near. So our main idea is to get rid of the power. Whenever I don't want the power, the only rescue is taking logarithm. So logarithm is an easy way which helps us to bring the power near. So it becomes x log x. Try to write it in quotient model. According to the question, rewrite it like a quotient model, and now it becomes simple as the previous class. The question is, when you apply the limit, it is logarithm. What should we do? Here we are using composite function rule, which tells us log of limit of some function or limit of log. Both are one and the same. Limit x tends to a or any value. Limit x tends to a, log of f of x is nothing but log of limit x tends to a f of x. Limit and log we can interchange. This we call composite function rule, and using this idea today we are going to do the problems. Exercise 7.5, question number 8, limit x tends to 0 plus x power x. The 0 plus tells us we approach 0 from the right side. The negative side is ignored. That is the major idea. The given problem, let us assume as y equal to x power x. Taking log on both the sides, log y equals log x power x, or I can rewrite it x log x, which can be still written as log x by 1 by x. The question is to find limit. If I apply directly limit here, it becomes 0 power 0, which is indeterminate. If I apply limit here, again it is 0 into log 0. 0 into log 0 when I substitute. Limit x tends to 0 plus x log x is 0 log 0. We know log 0 is minus infinity. 0 into minus infinity is also indeterminate. So, our only idea is to apply L'Hopital's rule. So, applying L'Hopital's rule, we differentiate numerator separately and denominator separately. Limit x tends to 0 plus log x by 1 by x, we can write limit x tends to 0 plus log x. Derivative is 1 by x. 1 by x, derivative is minus 1 by x square. Reciprocate, we get limit x tends to 0 plus 1 by x into minus x square by 1. We can cancel 1x and my answer is minus x value 0. We do not write minus 0, so 0 is the answer. Have I completed the problem? No. We had taken log And for logarithm, the limit is 0. Now we have to remember the rule. Log of limit x tends to 0 plus y. Y is the function name that we have taken, is nothing but limit x tends to 0 plus log y, and this answer only is 0 from here. Log of limit or limit of log, my answer is 0. But the question is not with logarithm. So what should I do? If I want to remove logarithm, the only rescue is take e power. Log y, the limit 0, tells me whenever I don't want log, raise it to e power 0, which is 1. So we will take and write the answer, the given question. Limit x tends to 0 plus x power x. We have arrived at 1, and that is the answer. Exercise 7.5, question number 9. Limit x tends to infinity 1 plus 1 by x the whole power x. If I substitute infinity, 1 by infinity is 0, 1 plus 0 is 1, 1 power infinity model. So 1 power infinity is indeterminate. So assume the given function as sum y. 1 plus 1 by x the whole power x. The very next step, take logarithm on both the sides. Power will come near. So it is log 1 plus 1 by x power x, or x log 1 plus 1 by x. Can you have x and log together in the numerator? To apply L'Hopital's rule, we need quotient pattern. Log cannot come down. Keep log in the numerator. Bring this x down. So it becomes 1 by x. Check whether you apply the limit. It helps you in any way. 1 by infinity, 0. This is also 0. Log 1 gives me 0 by 0 pattern only. So let me write limit x tends to infinity log 1 plus 1 by x by 1 by x gives me log 1 by 1 by infinity 0, which is 0 by 0, and that is also indeterminate. Applying L'Hopital's rule for log y. Differentiate the numerator separately and the denominator separately. Logarithm. What is log formula? Log will become 1 by x. Let us remember certain formula. Log x becomes 1 by x. 1 by x becomes minus 1 by x squared. Applying these formula here, log 1 plus 1 by x becomes 1 by 1 plus 1 by x. Whatever is in log will come as 1 by. Into hide logarithm. 1 will become 0. 1 by x will become minus 1 by x squared. Denominator also there is 1 by x. This 1 by x when I differentiate, again minus 1 by x squared. Applying the limit x tends to infinity. We can cancel this minus 1 by x squared in the numerator and denominator. As I cancel minus 1 by x squared, we are left with 1 by 1 plus 1 by x. Apply the limit 1 by 1 plus 1 by infinity. 1 by infinity becomes 0, 1 by 1 is 1. So we have got the limit value is 1 after taking logarithm. Let us remember the rule. Limit of log y or log of limit y, my answer is 1. What is the limit given? X tends to infinity. When I don't want log, I simply write limit x tends to infinity y is e power 1. With logarithm, my answer is 1. If I remove logarithm, it will become e power 1, which is e. Take and write the answer. The given question, limit x tends to infinity 1 plus 1 by x whole power x is equal to e. Exercise 7.5, question number 10, limit x tends to pi by 2 sin x power tan x. When I apply the limit, sin 90 is 1, tan 90 is infinity. So 1 power infinity, which is indeterminate. Let us assume the given function as y equals sin x power tan x. Taking logarithm, log y equals log sin x power tan x. Power comes near, so it is tan x into log sin x. Again, we cannot have 2 in the numerator. Bring tan x down. Log sin x divided by tan x in the numerator will come down as 1 by tan x, that is cot x. As I want to put the limit x tends to pi by 2 log y. Limit x tends to pi by 2 log sin x divided by cot x. As I substitute, it is log sin 90 is 1 by cot 90 is 0. Log 1 is 0 by 0, which is indeterminate form. So we apply Hospital's rule. Let us differentiate the numerator log sin x. Remember the formula, log x becomes 1 by x. So log sin x becomes 1 by sin x. Hide logarithm. Sin x will become cos x. Denominator, cot x is there. Cot x derivative, we must remember, minus cosecant square x. As we simplify, writing cosecant square x as x tends to pi by 2 cos x by sin x divided by minus 1 by sin square x. Cosecant square is nothing but 1 by sin square. Sin and 1 square will get cancelled. Reciprocating, limit x tends to pi by 2 cos x. This goes up, so it is minus sin x. As I apply the limit, minus cos pi by 2 sin pi by 2. Cos pi by 2 0, sin pi by 2 1. Together they become 0. Let us remember, limit of log y, log of limit y, the answer is 0. Limit is nothing but x tends to pi by 2. If I know limit of log and log of limit are 0, this implies limit of y when x tends to pi by 2. When we don't want log, the answer is e power 0. E power 0 is 1. Take and write the question. Limit x tends to pi by 2 sin x the whole power tan x is equal to 1, and that is the answer. Question number 11, limit x tends to 0 plus cos x power 1 by x square. If I put 0, cos 0 is 1, 1 by 0 is infinity. So this is indeterminate form. So as before, let us consider the given question as y. Cos x, the whole power 1 by x square is y. Taking log on both the sides, it is log cos x whole power 1 by x squared. Power comes near, so 1 by x squared log cos x. The question is, limit x tends to 0 plus log cos x by x squared. As I put 0, cos 0 is 1, I get log 1 by x 0, that is 0 by 0, which is again indeterminate form. So, we are applying L'Hopital's rule. As we apply L'Hopital's rule, let us differentiate numerator separately and denominator separately. Limit, there is no change, write as it is. Log cos x. Let us remember the formula. Log x becomes 1 by x. Cos x becomes minus sin x. And x squared, the formula we say x power n. That is nx power n minus 1. So it becomes 2x. Let us apply all this here. Log cos x will become 1 by cos x. Log x becomes 1 by x. Log cos x becomes 1 by cos x. Hide logarithm. Cos x will become minus sin x. The denominator x squared becomes 2x. As we apply, again we get 0 by 0, which is indeterminate. So we apply Hospital's rule once again. Sin by cos, we can write tan x by 2x. Applying L'Hopital's rule, we can write limit x tends to 0 plus tan x derivative. Let us remember tan x derivative secant square x. 2x becomes 1. As I put x value 0 minus secant square 0 by 2, that is minus 1 by 2. This is the limit value after taking logarithm. So we have to write limit of log y, log of limit y equals to minus 1 by 2. Limit x tends to 0 plus, remember to write it. The very next step. If I don't want logarithm, e power I have to raise. So limit x tends to 0 plus y equals e power minus half, or 1 by e power half, or 1 by half tells me square root. So I will write root of e. Take and write the answer. The question is limit x tends to 0 plus cos x power 1 by x square equals 1 by root of e, and that is the answer. Question number 12. If an initial amount of A naught money is invested at a rate R, compounded n times a year, the value of investment after t years is given like this. The interest is compounded continuously. Tells us limit n tends to infinity. So this given question, we need to find limit n tends to infinity. Limit n tends to infinity, a naught into 1 plus r by n whole power nt. A naught is not affected by the limit. Keep a naught out. Limit n tends to infinity, 1 plus r by n the whole power nt. So our problem is done if we find out this answer. When I put n is infinity, r by infinity will become 0. 1 plus 0 is 1. 1 power infinity will come. So this reduces to 1 power infinity, that is indeterminate. So as before, let us assume this problematic thing as y. So let y equals to 1 plus r by n whole power nt. Taking logarithm, log y equals log 1 plus r by n whole power nt. Power comes near nt log 1 plus r by n. Bringing nt down, log 1 plus r by n by 1 by nt. Even if I take limit here, I will again get indeterminate form. So let me put limit n tends to infinity log 1 plus r by n by 1 by nt. Log 1 plus r by infinity will become 0 by 1 by infinity. Log 1 is 0. 1 by infinity also 0. We get indeterminate form. So we apply HOPITAL'S rule. HOPITAL'S rule tells me differentiate numerator separately and denominator separately. Limit, there is no change. We write as it is. Log 1 plus r by n. Let us remember the formula. Log x becomes 1 by x. 1 by x becomes minus 1 by x square. In this question, it is not x but n. So we just change it. Log n becomes 1 by n. Remember, 1 by n becomes 1 by n square. Simple idea. Just in the place of x, we put n in the formula. Log 1 plus r by n, according to this 1 by. So log of what? That will come in the denominator into hide logarithm. We are left with 1, that becomes 0 plus r into 1 by n. The formula is minus 1 by n square divided by. Again 1 by n is coming. 1 by n. The formula is minus 1 by n square. There is 1 by t. Keep it as it is. As we simplify the problem, 1 by 1 plus r by infinity into r reciprocating 1 by t, I get into t. So this is r by infinity becomes 0. 1 plus 0, 1. So I am just left with RT. Let us remember the formula. Limit of log or log of limit, my answer is RT. Here we have taken y. So log of limit y or limit of log y, where limit n tends to infinity. My answer is RT. That implies limit n tends to infinity y equals e power RT. This let me call number 2. The original question we call number 1. So limit n tends to infinity of this part is e power RT. So I have to multiply with a0 to arrive at the required answer. 1 and 2 together imply, when the interest is compounded continuously, a equals a naught e power RT, and that is the answer. This problem alone is little difficult, so go through the problem again and again. The word interest is compounded continuously tells us n tends to infinity. So when limit n tends to infinity of the given problem, a naught being a coefficient, keep it out. It is not affected by the limit. It can be multiplied in the last step alone. This part, when I try to find the limit, it is 1 power infinity. So assume it as y, taking logarithm, and we apply L'Hopital's rule. We remember log n derivative is 1 by n derivative is minus 1 by n square. As we apply and we reciprocate, we are just left with RT. When logarithm is taken, limit is RT. So without logarithm, it is e power RT. Put this e power RT back in equation 1. We get A is A naught e power RT after t years when the interest is compounded continuously.